Voyager 1 was still answering commands in late 2023, but the data coming back from interstellar space had turned into a repeating stream of nonsense. The radio carrier was there. The spacecraft appeared alive. Its engineering and science reports were unreadable. Each command took more than 22 hours to arrive, and each reply took the same time back. Engineers traced the failure to the flight data subsystem, then discovered that part of its memory could no longer be used. No single healthy location had enough room for the damaged section of code, so the team split the code apart and moved it into several places. This episode follows a repair made across more than 15 billion miles, one slow exchange at a time. Voyager 1 has 3 onboard computers, each built with 1970s technology and a narrow job. The flight data subsystem packages science and engineering measurements for transmission. On November 14, 2023, Voyager stopped sending readable data from that system. Mission controllers could still see a steady signal and could tell the spacecraft was receiving commands. That split was useful. Power, radio transmission, and basic command handling had not disappeared. Something in the path that assembled the data was producing the repeated pattern. The team tested commands and watched for changes through the long round-trip delay. Remote troubleshooting normally depends on quick feedback, logs, and replacement hardware. Voyager offered none of those comforts. A test sent on Monday might not reveal its result until Tuesday, and a reckless command could silence the most distant working spacecraft. In March 2024, engineers sent what the team called a poke to the flight data subsystem. The command prompted the computer to try different software sequences. A later transmission contained a different pattern. An engineer with the Deep Space Network decoded that response and found a readout of the subsystem's memory. The readout let the team compare what Voyager stored with the code and variables they expected. One region stood out. A single memory chip that held part of the flight software appeared to have failed. That finding transformed the problem. Engineers no longer faced a vague stream of bad data. They had a damaged address range and could identify the code that depended on it. The chip could not be replaced, and commands could not make dead memory reliable. The software had to live somewhere else. Voyager's healthy memory did not contain one empty block large enough to hold the affected software section. Engineers therefore divided the code into pieces and planned to store those pieces in several locations. Moving code changes more than addresses. Other instructions that call it must know where to jump. References to variables must point to their new homes. Timing and memory use still have to fit a computer with almost no spare capacity. The team began with the portion needed to package engineering data. They relocated that code and updated the references that depended on it. The command itself traveled for more than 22 hours. On April 20th, Voyager returned usable engineering information for the first time in 5 months. The repair had not restored science yet, but the team could once again read the spacecraft's health. Engineering telemetry gave the team better visibility for the next step. On May 19th, controllers sent another command to restore the code paths that formatted science data. 2 of Voyager's 4 active science instruments returned to normal operation immediately. 2 needed additional adjustments. By June 13th, all 4 were sending usable science measurements again. Those instruments study magnetic fields, plasma waves, and charged particles in interstellar space. The recovery did not rewind Voyager to launch condition. It restored a specific chain. Instruments produced measurements, the flight data subsystem packaged them, the radio sent them, and Earth decoded them. Each recovered packet proved that the relocated software and its references were working inside a computer launched in 1977. Distance changed the rhythm of every choice. Voyager could not stream a diagnostic session or accept a quick rollback. The team prepared commands, checked them across mission specialists, sent them through the Deep Space Network, and waited almost 2 days for a complete round trip. The spacecraft also had limited electrical power and aged hardware. Memory changes had to coexist with systems that still controlled attitude, communication, and survival. Engineers used documentation, old code, test tools, and decades of accumulated knowledge about the twins. The technical feat is easy to frame as programmers patching an ancient computer. The deeper picture includes the network and the people who preserved enough understanding to change that computer after most of its designers had retired. Voyager's recovery did not make the spacecraft young. Its radioisotope power source loses output each year, and mission engineers continue switching off heaters and instruments to stretch the remaining electricity. In 2025 and 2026, NASA shut down additional science instruments as part of that planned decline. Those later decisions do not undo the 2024 repair. They clarify its purpose. The team was not preserving every function forever. It was recovering useful engineering and science data while enough power remained to collect them. Spacecraft rescue often means choosing which capability deserves the next watt, the next memory address, or the next command window. Voyager's extraordinary age makes those choices visible, but the logic is familiar. Protect the chain that can still produce unique value. Engineers repaired Voyager 1's unreadable data by diagnosing a failed memory chip and relocating the affected flight software. A poke command exposed a memory readout. The team identified the damaged region, split the required code across several healthy locations, and updated the references that connected those pieces. Engineering data returned in April 2024. All 4 active science instruments were sending usable data again by June. Nothing about the repair was instant, and none of it erased the limits of an aging spacecraft. It restored one precious thing, a readable account of the environment beyond the sun's protective bubble, sent by a machine more than 15 billion miles away. Voyager's age created another kind of redundancy, memory outside the spacecraft. Engineers retained software listings, interface knowledge, test methods, and a culture of checking commands before transmission. No spare flight computer could be launched across interstellar space, but the team could still reconstruct how the old one used its addresses. The repair depended on people treating documentation as working mission hardware rather than historical paperwork. Every recovered telemetry frame linked a 1977 computer to a 2024 analysis chain. The waiting shaped the repair's emotional rhythm. A command left Earth with no guarantee that Voyager would interpret it as expected. By the time the answer returned, the spacecraft had traveled millions more kilometers. The team could prepare the next branch, but it could not hurry the radio wave. That enforced patience makes the April engineering packet feel less like a normal status message and more like a distant machine finding its grammar again.